Okay, hi everyone. This video is to go over lesson 3.1, which is going to be on derivatives of polynomial functions and also using the power rule. And so last unit, we learned a formula for calculating the derivative or the slope of a tangent line. This chapter, we're going to be learning some tricks so that we can calculate derivatives much faster. So whereas a derivative before might have taken you a couple minutes to solve, now it's going to take you a couple seconds, which is great. Just a little reminder, derivatives are the slope of the tangent line to a function at a particular point. Derivative equals slope of tangent line. Okay, and here there are some basic differentiation rules which you need to know. So the first one is that when you have a constant function, let's say, for example, f of x equals 2. So that's just a horizontal line at the value y equals 2. Horizontal lines, remember, have a slope of 0, and so the derivative of that function would be 0 because the slope of the tangent line everywhere would be 0. So therefore, f prime at x equals 0. Notice we're using two different notations for derivatives here. We have the d by dx notation and then the f prime notation. So both are going to be used interchangeably throughout this chapter. Okay, next we have the constant multiple rule. So let's say you have a particular function that you know how to do the derivative of, and then there's a constant multiplied to it. In that case, you can just do the derivative of the function and then multiply the constant to your answer. So we'll be seeing an example of number 2 down below. The sum and difference rules, let's say you know how to do the derivative of two different functions separately. If those two functions are being added together, then you can just do the derivatives and add them together. Again, we'll see an example of that below. And then the last one here is really key. This one we're going to be using in almost every question today. The derivative of x to the power of n could be any number, 1, 2, 3, 4, it could be negative, could be a fraction, any kind of power. You're going to, the derivative would be bring the n down, and then you subtract the power by 1. So I'm just going to do a quick example here. Let's say we have f of x equals x cubed. Okay, so the power rule says to find the derivative, we bring the 3 down, and then we reduce the power by 1, so it becomes 3x squared. Okay, this works with negative powers too. So if you had x to the power of negative 2, for example, then you would bring the negative 2 down, and you would reduce the power by 1, so it would become negative 3. It even works for fractions. So let's say you had x to the power of 1/2. Then the derivative would be, so the 1/2 would come down, and we would reduce the power by 1. So 1/2 minus 1 is negative 1/2. So it'd be 1/2 to the x to the power of negative 1/2. So that's how the power rule works. And so those are the 4 basic rules we're going to be using today to find derivatives. So we're going to kind of combine all 4 rules in some of the questions. Okay, let's start off with a simple one. Let's say our function is f of x equals 3, which is a constant function. So remember, that's just a horizontal line at the value y equals 3. So that would have a slope of 0. So rule number 1 applies here, and the derivative equals 0. All constant functions by themselves have a derivative of 0. Okay, here we have 5 multiplied with x squared. So in this case, so I'm going to use rule number 2 and number 4 here. So we know how to take the derivative of x squared, and we just have a 5 in front. So what rule number 2 says is just ignore that constant and multiply it in with the answer that you get. So I'll show you what I mean. So I'm just going to leave the 5 where it is and focus on doing the derivative of x squared. So the derivative of x squared, we use the power rule, rule number 4 above. So bring the 2 down and reduce the power by 1. And that's your derivative. We shouldn't leave it in this format, though. We should combine the 5 and the 2 together. So let's rewrite this. So 5 times 2 is 10. And we don't need the power of 1 to be written down. We just leave it as x. So that would be your final answer there. Okay. Next question. We have 2 different terms added together here. We have square root of x and we have 10. We know how to do the derivative of 10. That's a constant, and so the derivative of that would be 0. The square root of x, we need to rewrite it because right now none of my rules above have any square roots. But you need to recall that root x is the same as x to the power of 1/2. And when written like that, we can use the power rule and we know how to do the derivative. So I'm just going to rewrite this function. It's the same as x to the power of 1/2 plus 10. Okay, I'm not doing the derivative yet. I'm just rewriting the function. So therefore, the derivative would be, so for the x to the power of 1/2, we bring the 1/2 down, and then we reduce the power by 1. So -1/2. And the derivative of 10 is 0. Of course, you don't have to write plus 0 because that doesn't really change the function at all. So you can just leave it as 1/2 x to the power of -1/2. And sometimes in the answer key, you'll see it written like this. Other times you might see, so remember with negative powers, you can bring them into the denominator and they become positive. So you might see it written like this instead, or you might see it changed back into a square root at the end. Any of those are fine. So I'll accept any answer. I just wanted you to be aware that some answer keys have different ways of writing their final answers, so you should know how to change it back and forth. Okay, next one. We have 4 being divided by x cubed. Up above here, we don't have any mention of constant division, like division anywhere, right? So we have to again rewrite this in order to use our rules above. So remember, if your power is in the denominator, oops, I'm just going to rewrite the function. You can bring it up into the numerator just by making the exponent negative. And now I can use the constant multiple rule and the power rule to solve this. So remember, if you just have that constant multiplied, you can just leave it where it is, ignore it, and multiply it to the final answer. And for the power here, we're going to bring the 3 down and reduce the power by 1. And I'll write this a little bit nicer. This is -12 x to the power of -4. And you can also write this as -12 over x to the power of +4. Again, I'll accept either one. It's just some answer keys write their final answers one way and some write them another way, so you should be aware of both. Okay. Next question. We're going to have 3 terms in this degree 2 polynomial. So this is a parabola. So we're getting, because the terms are being subtracted from one another, we can just do them all 3 terms separately and just add the derivatives together at the end. So for the 6x squared, remember we leave the 6 where it is. For the x squared part, we bring the 2 down, reduce the power by 1. For 2x, remember x has a power of 1. So we still use the power rule. We're going to leave the 2 where it is. The 1's going to come down and we're going to reduce the power by 1. And for the 8, that's a constant, so the derivative is 0. We're going to clean this up a bit. So 6 times 2 is 12. We do not need to write the power of 1. And 2 times 1 is 2. X to the power of 0 is 1. x to the power of 0 equals 1. So that basically, you don't actually need to write it down because multiplying by 1 doesn't change the number. So 2 times 1 is 2. And the plus 0, again, you can just leave it off. So with my derivative here, I have 12x minus 2. Okay, next one. We have 3x plus 1 all squared. We haven't learned a rule yet for when a term in a function is being squared. We don't have a rule for that. So we are going to rewrite this in order to find the derivative. We're going to expand it out. I'm just going to rewrite it as two terms being multiplied together so you can see how I FOIL it. So we just FOIL it out. So 3x times 3x is 9x squared. 3x times 1 is 3x. 1 times 3x is 3x. And 1 times 1 is 1. And I'll just combine like terms. If you're able to do that in one step, no worries, you can do that. Okay, now that I have my three separate terms, I can do the derivative of each one and add them together. Okay, the derivative of 9x squared. So I'm going to do this in one step now. If you want to use two steps, that's totally fine. So remember, you leave the 9 where it is. The 2 is going to come down in front and multiply with that 9. So it's going to make 18. And we're going to reduce the power of that x by 1. So it's just going to become 18x. Now in this next term, the 1 on the x is going to come down and multiply with the 6. And it's going to be x to the power of 0. Which you don't need to write because that's equal to 1. And the derivative of 1 is 0. So there's our derivative. Again, if you're not comfortable with doing that in one step, just use two steps, that's fine. Okay, and lastly, we have a rational function here. X squared minus x is in the numerator and square root of x is in the denominator. We don't have a quotient rule yet. We don't have a rule for when we have different terms being divided. So we need to rewrite this function. In order to rewrite it, I'm going to just split that fraction apart. So this is the same as x squared over, and I'm going to rewrite the square root as a regular power, so it's x to the half. Minus x over x to the half. And if you recall, one of our exponent rules is that when you're dividing powers of the same base, you can just subtract the exponents. I'm just going to write that here, subtract exponents when dividing, in case you forgot that, powers of the same base. So we can rewrite that as, so 2 minus a half is 3 over 2. And this has a power of 1. So 1 minus a half is a half. Okay, so that's the original function, just rewritten in separate terms. And now I can just use the power rule to find the derivative. So f prime, excuse me, f prime of x is, okay, so for the 3/2, we bring the 3 over 2 down, and we reduce the power by 1. So 3 over 2 minus 1 is 1/2. And the x to the power of 1/2, we bring that down, and we reduce the power by 1. You can write your answer like this, or in the answer key, you may see it written with the square roots. And remember, you can bring the negative power into the denominator to make it positive. Either answer is acceptable, both are totally fine. I'll accept both on the test. It's actually better to leave it in the first form so you don't make a mistake changing it over. Yeah, and that's it. So the main idea today is learning the power rule. And then also, if your function is not written in separate terms, you need to change it or rewrite it using some algebra skills in order to write it into separate terms, just like we did in questions F and G there. Okay, so the assignment is written there. And as always, all the required question solutions are on Teams, and then the extra practice solutions, you can find them on slater.com. All right, I'm just going to end the meeting.